In this video, you will learn about the slope-intercept form of a linear equation. So what is a slope-intercept form? Well, what it is it's a quick way to find the slope and y-intercept given an equation of a line. Now to do this, we want to put it into slope-intercept format, and that's going to look like this: y equals mx plus b. So this is slope-intercept form, where it's solved for y, and m is a number with the x, and m is going to be your slope. And then b, the number being added or subtracted, is the y-intercept, which by definition, the y-intercept is where it intercepts or crosses the y-axis. So for example, let's say we had y equals 2x plus 4. Notice it is in the format y equals mx plus b. So m is going to be 2, the number with x, so the slope is 2, and b, your y-intercept, is going to be 4. Now what does that mean graphically? Well, the y-intercept is where it crosses the y-axis. So this vertical line is your y-axis, and it's going to cross at 4, which would be right up here. And then from here, we have the slope, and slope, remember, is rise over run. So if I write 2 as a fraction, it's going to be 2 over 1. So that means from this point, I'm going to go up 2 and to the right 1. That gives me this point right here. And once we have the 2 points, we can connect the dots and graph. So notice that having the slope and y-intercept makes it very quick to graph the equation. Let's look at another example. Here we have y equals 6 over 5x minus 3. Notice that this is in slope-intercept form. We have y equals mx plus b, where m is going to be 6 over 5. That's the number with the x term right here. And then b is the number being added or subtracted. That's out here. So b, or the y-intercept, would equal negative 3. So we very quickly can graph based off this information. The y-intercept is negative 3. That is where it crosses the y-axis, which is this vertical line. And so that crosses at negative 3, which is right here. And then the slope is 6 over 5, which, remember, slope is rise over run. So that means we go up 6 and then to the right 5. So from this point, I go up 6 over 5, and that takes me right here to this point. And then I connect the dots, and this is my graph. So notice how quick this is to graph the equation if you have this in the correct format. Another example, we have y equals 5 over 2 minus 2x. Now this one, just be careful because the format is a little off. Remember, we want y equals mx plus b. If it's helpful, you can rearrange this a little bit. So I can rearrange this equation as y equals, and then we put the x term first, so negative 2x would come first, and then plus the 5 over 2. So if you look at it like this, we can see very quickly that the slope is going to be this negative 2 because it is with the x, and then b would be 5 over 2 because that is the number being added on the side. So slope is negative 2 and y-intercept is 5 over 2. Now you don't need to rearrange like this. You can maybe just look at the equation and realize that this part with the x is going to be your slope, and then this part by itself is going to be the y-intercept. But it might be helpful if you rearrange it into the correct format first. Now from here we can graph very quickly. The y-intercept is 5 over 2, which is 2.5, and that's where it crosses the y-axis. So on the y-axis, I go up 2.5 to get this point right here. It's between 2 and 3. And then the slope is negative 2, and slope, remember, is rise over run. And Negative 2 we can write as a fraction, negative 2 over 1, which means the rise is negative 2. So from here I go down 2, and then the run is 1, so I go to the right 1. That takes me right here at the point 1, and then 1/2 for y. I connect the dots, and I get this graph right here. Here is another example where we have an equation, but it's not in the correct format. So there's different ways you can put it in the correct format, but bottom line, I need to get y by itself. So y equals something. So to do that, I need to get rid of the x, the negative, and the 1. And like I said, there's different ways we can do this, but if we move everything from the y, we would begin maybe by subtracting the x over. When I do that, the x's will cancel over here. So now I have negative y plus 1 equals negative x. I need to bring the 1 over, so I can do that by subtracting 1. That will cancel over here. I now have negative y equals negative x minus 1. However, we want a positive y on the left side. So if I think of this as dividing everything by negative 1, then the negatives over here become a positive. So that becomes a positive y. And then the signs over here change. So instead of negative x, we have positive x. And instead of negative 1, we have positive 1. So this would be y equals x plus 1. Now, from here, we have this in the correct format. This is slope-intercept form, right? Because we have y equals, then mx plus b. So m is the number with x. And notice there's nothing written in front, which is always an assumed 1. We have 1x. So the slope is going to be 1, because that is the number with x. And then your y-intercept is this plus 1 that's being added. So slope is 1, and y-intercept is 1. Now, we could graph this if we wanted, and we're not going to do that for this example, but we could if we wanted to. Okay, example 5. This one we will graph, and we have the equation 4x minus 3y equals 3. So to graph this, we can put this in a slope-intercept form. So we can get it to look like y equals mx plus b. So we want to get y by itself, which means we must get rid of the 4x and the minus 3. And to move things around, we need to do reverse order of operations. This 4x is being added, this negative 3 is being multiplied. So get rid of the addition first. We do that by doing the opposite, which is subtracting. So I subtract 4x from both sides. These negative 4x's will cancel. I have negative 3y on the left, and on the right we have 3 minus 4x, or we can write that as negative 4x plus 3. And then from here, we need to get rid of this negative 3 that is with the y. And to do that, we do the inverse of multiplying, which is dividing. So I divide everything by negative 3. I now have positive y on the left, and then on the right we have positive 4 over 3x, and then 3 divided by negative 3 is negative 1. So now it's in the correct format, where m is going to be the 4 over 3, and that's your slope. Then b, or your y-intercept, is this minus 1. So to graph, the y-intercept is negative 1, so that's where it crosses the y-axis, and that's going to be right here at negative 1. And then slope is 4 over 3, and slope, remember, is rise over run. So the 4 is my rise, so from this point right here, I go up 4, and the run is 3, so I go to the right 3 to get this point right here. And then we can connect the dots, and we get this line right there. Okay, now we have another concept, and that is with parallel lines and then with perpendicular lines. There is a relationship between the slopes of parallel lines and then of two perpendicular lines. So first off, we need to make sure that we understand what parallel lines mean. So parallel lines, by definition, are going to be two lines like this that never intersect. Okay, so these lines are parallel. And the slopes of parallel lines will always be the same. So for example, if the slope of this line right here is 3, then the slope of this parallel line would also equal 3. So parallel lines always have the same slope. Now perpendicular lines are two lines that intersect at 90 degrees. So right here we see two perpendicular lines, and notice they form a 90-degree angle. So with perpendicular lines, the relationship is that the slopes are negative reciprocals of each other. So for example, if the slope of line 1 is 2 over 3, let's say this is line 1 and the slope is 2 over 3, then the slope of this line over here, the perpendicular line, is the negative reciprocal. So the positive becomes negative, and instead of 2 over 3, it's going to be 3 over 2. So we change the sign, and then we flip the top and the bottom. So the slope of line 2 would be negative 3 over 2. Now you need to determine, based off the slopes, if the two lines are parallel, perpendicular, or neither. This will give us some practice with this concept. So if the two lines have a slope of 3/4 and 12 over 16, what type of lines do we have? Are they parallel, perpendicular, or neither? Well, notice 12 over 16 can reduce by dividing the top and the bottom by 4. And that's going to give me 3 over 4. So notice, same slope. They both have a slope of 3 over 4, so therefore, these lines would be parallel. Example 2, if we had 1 and negative 1, are the lines parallel, perpendicular, or neither? Well, we know that it cannot be parallel because parallel needs to have the same slope. This is not the same slope. So maybe it's perpendicular. Well, perpendicular needs to be negative reciprocals. So if we look at 1, I can think of 1 as 1 over 1. So to find the perpendicular line, the slope of that line, we need to make it negative and then reciprocal. We switch the top and the bottom. So now we have, it's still going to be 1 over 1, right? So that's going to be negative 1. So the reciprocal, the negative reciprocal of 1 is negative 1. So because of that, 1 and negative 1 are negative reciprocals, which means that the lines would be perpendicular if that was the slope. Now what if you had 3 and negative 3? Would this be perpendicular as well? Well, in this case, it would not be, because if we look at the slope of 3, so we got to make it a negative reciprocal. So 3 is the same thing as 3 over 1. Negative reciprocal, change the sign to negative. We flip the top and the bottom to get 1 over 3. So the negative reciprocal is negative 1 over 3, which is not the same thing as negative 3. So therefore, these are not negative reciprocals of each other, so these lines would not be parallel or perpendicular. Now let's increase the difficulty and put everything together from this lesson. So here we are given two equations, 3x plus y equals 6 and 3x plus y equals 1. We know that if we graph these equations, we will have created a line. So the question is, will these lines be parallel, perpendicular, or neither? So to determine this, we need to look at the slopes. If the slopes are the same, then it's parallel. If the slopes are negative reciprocals of each other, then the lines are perpendicular. And if neither of those, then it's not parallel or perpendicular. So what we must do is we need to rearrange this into slope-intercept form so that we can very quickly see what the slope is. So looking at this first equation, 3x plus y equals 6, I need to get y by itself so that it looks like y equals mx plus b. So I can bring the 3x to the right side, and I do that by subtracting. So when I subtract, we have y equals 6 minus 3x, or we can think of that as negative 3x plus 6. The other equation, same thing, we need to subtract 3x from both sides. So now we have y equals negative 3x plus 1. Now at this point, we can tell very quickly what the slope is. The slope is going to be the part with the x. So this negative 3 is going to be your slope for that equation. Then over here, we have negative 3 as well for that slope. So the slope is negative 3 right there. And if we wanted the y-intercept, we could establish that as well to be 6 for this equation, and then 1 for the second equation. But all that we need to look at is going to be these slopes right here. If the slopes are the same, which they are, then the lines are parallel. So the lines are parallel because the slopes are the same, and the y-intercept is different. So that means we have two different lines. So I mean, we don't want two lines with the same slope, but they're on top of each other like this, because that's the same line. So we have two different lines, as we can see, but the slopes are the same. One more example like that, we have 3x plus y equals 6, and negative 1/3 x plus y equals negative 2. And again, we are to determine what type of lines we have, if they're parallel, perpendicular, or neither. So again, I must rearrange and write the equation in slope-intercept form. So this 3x plus y equals 6, I can bring the 3x to the right side to make it look like y equals mx plus b. So I do that by subtracting 3x, that brings it over. So over here the 3x's cancel. I have y equals 6 minus 3x, or same thing as negative 3x plus 6. For the second equation, I need to bring over the negative 1/3 x to the right side, and I do that by adding 1/3 x to both sides. So I add 1/3 x to both sides. Now we'll get this negative 1/3 x to cancel out. We now have y equals negative 2 plus 1/3 x, or I can think of that as 1/3 x minus 2. So now they're both in slope-intercept form. First equation, I can see the slope to be this negative 3 right here, and then the y-intercept would be the 6. Second equation, the slope is 1/3, and the y-intercept is negative 2. So we have two different lines with two different slopes, and if we compare the slopes right here, notice the one is negative 3, so I can think of that as negative 3 over 1. If I take the negative reciprocal of that, so change the sign to a positive, then flip the top and the bottom to become 1 over 3, then we do have the slope of the second equation. So negative 3 and 1 over 3 are negative reciprocals of each other. So because of that, the lines are perpendicular. And that concludes our lesson for today. We will see you next time.